Hey Math Scholars, I'm excited for another lesson today. And as always, we start with our do now. It's a word problem that connects to what we learned on Friday of last week. So if you need to get your notes out, then now's a good chance to do that. You have this do now question. You can copy it down if you want, but you don't necessarily have to. But you should think about how or what you would circle, underline, box, evaluate, solve, and check, right? Cubes doesn't go away just because we're doing it virtually. All right, so we have our question. 2 record low temperatures for Anchorage, Alaska are negative 34 degrees Fahrenheit in January and 31 degrees Fahrenheit in August. Find the difference between these 2 temperatures. The first thing I have to do is circle my numbers, so that's negative 34 and 31. I underline the question. In this case, it's a little tricky because there isn't an actual question mark. It's telling us what to do to find the difference between these 2 temperatures. And I box any keywords that are there for me. And the key word here is difference, which tells me to subtract, right? So then I evaluate, which means I set up my problem, which is negative 34 minus 31. Now, some of us in the last lesson had a little trouble thinking about this. Some of us wanted to say, well, it's 3 degrees, right? Because 34 minus 31 is 3. But I drew this kind of number line up here for you to think about this. This is August at 31 degrees Fahrenheit. This is January. If this is 31 degrees, there's at least 31 spaces in here. And if this is negative 34, there's at least 34 spaces in here, which means it is way more than just 3 degrees between 31 and negative 34. It goes across the whole number line, which means when I set up my problem, negative 34 minus 31, and I LCO, it actually turns into negative 34 plus negative 31, which at the end of the day is negative 65. However, because we're talking about the difference, right, we don't have to include a sign because we're just talking about the number of degrees. So our answer here is, I'm really excited about today's lesson because often I find that when students are able to make discoveries about math on their own, they remember it better and it's just a better way to interact with math. And let's face it, all the things that we know about math were discoveries by some mathematician somewhere in history, right? We had no idea how to find the area of a circle until a mathematician figured that out. And so we're going to be doing some discovering today. You should have already worked through the discovery activity on your own PowerPoint and saved a copy to it. And submitted it to the assignment folder in Schoology. If you have not, stop the video and go back and do it. And now we're just going to go over those answers, and we're going to think about what's happening here. So the first thing that we asked, or that I asked you to do, was how can we represent multiplication on the number line? Remember that 3 times 2 is really saying 3 groups of 2. Right? And so once upon a time, probably in elementary school, you learned that if you do 1 group with 2, 2 groups with 2, and 3 groups with 2, and you counted all of them together, that would give you your product, right? 1, 2, 3, 4, 5, 6. So 3 times 2, we should already know, is 6, right? But we've been doing a lot of work on the number line because that's how we really think about rational numbers. And so if I want to represent that on the number line, I would use kind of my curved arrows to show that. So 3 groups of 2, right? 1 group of 2 would be here. The next group of 2 would be here. And the next group of 2 would be here. So this is 2, 2, and 2. Which also reminds us that 3 times 2 is the same thing as 2 plus 2 plus 2. And then we also have to remember that 3 times 2 we could also write as 2 times 3. Now, it does look a little different on the number line, right? In this case, I've got two groups of 3. So I have one group of 3 and one group of 3. But the answer is still 6, right? So this is the commutative property of multiplication. Doesn't matter what order the numbers are in, you'll get the same product. Sometimes we do our best learning when we discover. There we go. So now I want to think about what does 3 times negative 2 look like on the number line? Well, this is the same thing as 3 groups of negative 2. So here's negative 2, here's negative 2, and here's negative 2, right? 3 groups of them. And if I count them, 1, 2, 3, 4, 5, 6, 3 times negative 2 is going to be negative 6. On the number line, it looks like this. Here's one group of negative 2, another group of negative 2, and another group of negative 2. Look where we wind up, negative 6, right? And just like before, we can change the order of these numbers. We can do 2 groups of negative 3, negative 3 and negative 3, and get the same answer. Now. All right. So the next thing I asked you to do was fill in the table with your observations here, right? And so the first line says 3 times 2, and the equivalent sum, right, is 3 groups of 2, so I add 2 plus 2 plus 2. So that answer is 6, and our answer is positive. And then when I did the same thing with 3 times negative 2, I added negative 2 plus negative 2 plus negative 2. And there, I found my answer to be negative 6, and my sign was negative. Well then, 2 times 5 would be 5 plus 5. 5 plus 5 is 10, and that sign is positive. 2 times negative 5 then would be negative 5 plus negative 5. So that answer is negative 10. My sign is negative. So then on your own, you had to figure out 4 times 3. How would you write that as a number sentence? Well, that's 4 groups of 3. So you should have 3 plus 3 plus 3 plus 3. When I add those together, I get positive 12. My sign is positive. But when I multiply 4 times negative 3, or have 4 groups of negative 3, I get negative 12, and my sign is negative. Take a look at this table and think about what you're noticing here. Do you notice a pattern? Is there something that we can say about multiplying integers?
When you made your
So when you observed the signs of the product of 2 positive integers, what did you notice? Your answers can be all kinds of things, but the main one is that a positive times a positive equals positive. So when I multiply 3 times 8, it's going to be 24, and it's always going to be positive 24. And then what you notice when you multiplied a positive and negative, right? A positive and negative would be here and here and here. Our answers were negative, negative, negative. So in that case, what do you observe about the sign of a positive and a negative integer? Okay, when I multiply a positive by a negative, our answer is always going to be negative. And this makes sense when we think about our number line because we're moving farther to the left. All right, so now I'm going to throw a wrench in what we're talking about. now I'm going to think about, what does negative 3 times 2 look like? Well, I don't understand. So before we had 3 times negative 2. 3 groups of negative 2. But here, right, I have negative 3 groups of 2. Well, I don't understand. I don't know what a negative group is. You know, just kind of like distance. You can't really have negative groups because that doesn't really happen. So this doesn't really say negative 3 times 2. It actually says the opposite, right? Because the negative sign tells us the opposite. So it's really saying, what is the opposite of 3 groups of 2? So here are my 3 groups of 2, plus 2, plus 2, plus 2, and that would be 6. And then the opposite of 6 would be negative 6. So negative 3 times 2 is negative 6. The opposite of 3 times 2 is negative 6. Now I want you to think about how So then you had a chance to try it on your own number line. And I asked you to model negative 3 times negative 2. And again, we can't have negative groups. So what this is really saying is the opposite of 3 groups of negative 2. So on my number line, I should have one group of negative 2, another group of negative 2. Hey students.
Hey students, I play with Elsa.
She's playing with Elsa.
And you want to see her flips?
Oh my goodness, she's flipping. Woo. All right, so we have one group of negative 2, 2 groups of negative 2, and one more group of negative 2. So that's 3 groups of negative 2, which leads me to negative 6. So here, I'm thinking about the opposite of negative 6. The opposite of negative 6 would be over here, right? On the other side of the number line. So the opposite of negative 6 is 6. Negative 3 times negative 2 is equal to positive 6. The opposite of 3 times negative 2 is positive 6. So using those two models to try to build our understanding, we had another table to fill out. The first line is filled out already because we did it on the last slide. And then we started with negative 2 times negative 5, which is also saying the opposite of 2 times negative 5, or the opposite of negative 10. So the answer here is positive 10, because the opposite of negative 10 is positive 10, and my sign is positive. So again, if I have negative 4 times negative 3, what that's really saying is negative, or the opposite of 4 times negative 5. Well, if that's the case, it's the opposite of 4 times negative 5, or the opposite of negative 20. So the opposite of negative 20, what would be on the other side of the number line, would be positive 20.
Are you done?
Not yet. So if it's positive 20, notice what happens every time we have a negative.
Next, we're going to think about.
Are you done?
Not yet. So as you're reflecting, what do you notice is the same between multiplying integers in slide 3 and multiplying integers in slide 7? What did you notice about the signs? One of your answers should probably be if they have the same sign, like both positive or both negative,
Toothpaste.
the product
Toothpaste.
is always positive. Then I pushed you to think about rules. If you were to write rules for multiplying integers, what would you say? Here's something to get you started. When you multiply two positive integers, the answer is always positive. Another rule is
Okay.
when you multiply a negative by a positive, the answer is always negative. And then the last one that we just learned is when you multiply two negatives,
what do you do? I read in my comic book.
the answer is always negative. I hope this helps thinking about the reflection. We're going to pause here, and I hope you all enjoyed your self-discovery or your math discovery lesson as much as I hope you do, because it's just a really useful tool when we have to learn something, especially when what we're learning requires to memorize rules. So thinking about what we did in our kind of discovery part of the lesson, it makes sense that our objective for today is students will be able to multiply integers. So right now, you should have the following things on your desk. You should have your spiral notebook or 3-ring binder where you're keeping your notes. You should have a pencil. And you should also have your flow chart with adding and subtracting integers, because you're actually going to do some drawing today. So you should have those 3 things out. If you need to, pause and give yourself a chance to get your materials out and ready. All right, so our objective is to be able to multiply integers. That's all we're doing today. And so here is our flow chart for multiplying integers. If you would please turn your flow chart for adding and subtracting integers over to the blank side and go ahead and draw this flow chart that you see here. It does not have to be perfect. It just needs to make sense to you. So make sure that your handwriting is maybe a little bit nicer than normal so that you can go back and read it later. What the flow chart is telling us that we do the following things. The first thing we do is we multiply the values. Then we have to ask ourselves, just like we asked ourselves for adding or subtracting, is do we have same or different signs? If we have same signs, the answer is always going to be positive. And if we have different signs, the answer is always going to be negative. Let's try a couple together. Right? So go ahead and write down this first example, -5 times 4. This might be new notation to you, but when we have a number right outside of a parentheses like this, that's really saying -5 times 4 or -5 times 4 like this. By 7th grade, we were trying to get away from using the time sign that looks like an X because it looks like an X, and we're getting more and more into algebraic reasoning and thinking, so we don't usually write multiplication this way. You'll also see the dot in the middle, and you'll notice that here I have, I use the asterisk as well. All of these things mean multiply. Okay? So we have -5 times 4. And -5 times 4, I multiply my values first. I do 5 times 4. That's 20. And then I ask myself, do I have same or different signs? Well, I'm multiplying a negative by a positive, so my answer is negative 20. The next question I have is negative 3 times negative 9. I just multiply the values, 3 and 9, which is 27. And then I ask myself, do I have same or different signs? Both of these are negatives. So that means if they have the same signs, the answer is positive 27. You do not have to write the positive sign. I just like to write it here to remind myself. Now this next question has 3 factors, but that doesn't really change anything, right? We still, much like when we have an addition problem with 3 addends, we take it 2 integers at a time. I want you to think though right now, just predicting, make a prediction. Is this answer going to be positive or negative? What do you think? All right, so let's see if your prediction is right. I'm going to go ahead and do 2 times 3 first, which is 6. And then I ask myself, do they have same or different signs? This is a positive and this is a negative. So my answer is negative 6. And then I bring down my negative 7. Now I multiply 6 times 7, which is 42. And I ask myself, do they have same or different signs? It's a negative and a negative, so the answer here is positive 42. Take a second, mark any of these that you have questions about so that when we have our office hours on Wednesday, you can stop by and ask. Now we're going to move on to your examples. All right, on your own, I want you to go ahead and solve these 3 problems. The video is going to pause, give you an opportunity to answer them, and then we'll be back. Okay, so here are our answers to your questions. 9 times negative 8 is negative 72 because they have different signs.
I did not use it.
Okay, 1 second. And then we have negative 7 times negative 5, which is positive 35 because I'm multiplying 2 negatives. And then finally, 3 times negative 4 times positive 6, I have to take it 2 integers at a time. So 3 times negative 4 is negative 12. They're different signs. And I bring down the multiply by 6. So then I have negative 12 times positive 6. So I have 72, and because they're different signs, I get negative 72. You're going to have an exit ticket in Schoology for you to complete. It's a little bit longer than normal because this is a fairly quick lesson. If you have questions, please make sure you ask them before you hit submit. And I will see you either on Monday and Tuesday or Thursday and Friday.